I came across this article and it's a fascinating read. I've always been into black holes and astronomy in general. This comes out of futurism.com. Scientists calculate that the entire Big Bang must have taken place inside a black hole, and we're still trapped inside it. I mean, maybe possible. Maybe. I mean, if there's one thing that we're sure of about black holes is that we don't know anything about black holes, at least what goes on inside them. We just theorize, at least the math seems to suggest that the singularity, which is the center of the black hole, is infinitely dense and I don't know about infinitely massive. I mean, it's only as massive as the amount of matter that it swallows. But I mean, it sounds kind of reminiscent to what a Big Bang could potentially have been or could be. I mean, our Big Bang, infinitely dense, infinitely massive, infinite gravity, and then all of a sudden it was just unleashed into the universe we know today. So, anyway, I'll go ahead and get started on this. The standard model of cosmology may be the best explanation we've got for why the universe is the way it is and how it all came to be, but it's not the only explanation. Enter black hole cosmology. It's a radical idea which proposes that the Big Bang, the rapid unraveling of an infinitely dense point, believed to have given birth to the cosmos as we know it. It actually took place in a black hole, which itself formed inside a larger parent universe. Ergo, all of us in every star, planet, galaxy, and internet rando are living inside one of these mysterious singularities. Now, that's always what I've looked at from my own point of view. I mean, our universe has black holes all over the place. There are supermassive black holes at the center of most, if not all, galaxies. And then there's also really small black holes, stellar mass black holes, which are created from large stars that collapse after they've reached a certain point in their life where they can't sustain themselves anymore, and it implodes and then also explodes as well. But after that event is done, which is called a supernova or a hypernova, a black hole is left over. And it just simply exists in our universe. But my opinion, I've always thought, and I've not really read this anywhere, that a black hole. So Stephen Hawking, he theorized that black holes evaporate over very long stretches of time. We're talking like probably duodecillions of years, decillions and decillions of years, like insane amounts of time that it takes for a black hole, especially a supermassive black hole, to eventually just evaporate away. And if that's the case, then you know the whole universe is like, is it really here? If it's all gone one day, I mean, I don't know. That's more of the philosophical realm, but maybe it's not evaporating over long periods of time. Maybe instead, the black hole is being pushed out of our universe through the fabric of space and time because the black hole it has infinite gravity, or as close to infinite as math can at least suggest. And maybe it's not evaporating; it's very slowly being pushed out of our universe. And from our point of view, it's getting smaller and smaller. But I mean, I could maybe compare it to like if you splash water up on the ceiling and then you see like the drops, and when a drop drips from the ceiling, the top of the drop that's connected to the ceiling, it gets skinnier and skinnier, smaller and smaller until the drop falls. And that may be similar to what happens to a black hole in our universe. And once it's squeezed out of the fabric of space and time through our universe, and it's no longer bound by the laws of physics that our universe has, it explodes into a big bang, releasing all of the energy, all of the matter that it collected while it existed in our universe. So some black holes may produce very large universes, and other black holes may produce much smaller universes, such as those little stellar mass black holes that are only like 10, 15 miles across. I don't know. It's just a personal theory. Not sure if that really, you know, is possible or not. I don't know. I'm no physicist. I'm just an astronomy enthusiast. But it seems like the article kind of seems to possibly hint towards something like that, but not really quite. But anyway, so this guy, his name is Enrique uh, Gaztanaga. I'm sure I'm saying that wrong. Gaztanaga, probably, maybe. Yeah, probably. I don't know, whatever. Lead author of a new study published in the journal Physical Review D, and a professor at the Institute of Cosmology and Gravitation at the University of Portsmouth, isn't the first to propose this controversial idea, but his team's research offers a new model for imagining how this hypothetical scenario took place. Quote, our calculations suggest the Big Bang was not the start of everything, but rather the outcome of a gravitational crunch or collapse that formed a very massive black hole, followed by a bounce inside it, Gastanaga wrote in an essay for The Conversation. Certainly, there are a lot of holes that you could poke in the standard model. No pun intended. Why is there more matter than antimatter when the universe should be uniform? Why did the universe undergo a period of cosmic inflation in which it expanded at faster than light speeds and then stopped? And why does its present day rate of expansion appear to be different depending on how we measure it? Gaztanaga's main gripe seems to be with our current understanding of a singularity. To him, the idea of the universe starting as a point of infinite density is immensely unsatisfying. Yeah, I mean, I could agree with that. This is not just a technical glitch. It's a deep theoretical problem that suggests we don't really understand the beginning at all, he wrote. Gaztanaga also takes aim at other convenient cosmological constructions like dark energy, which is intended to explain why the universe's expansion is mysteriously accelerating. This hypothetical force is thought to make up 68% of the universe, but is completely unobservable, leaving room for different-minded scientists to call its existence into question. Rethinking singularities could neatly resolve many of these conundrums. We return to Gastanaga's paper. Gravitational collapse does not have to end in a singularity, he wrote for The Conversation. Our maths show that as we approach the potential singularity, the size of the universe changes as a hyperbolic function of cosmic time. This is a bold claim. The consensus is that gravitational collapse, like a star imploding into a black hole, must result in an infinitely dense singularity. What Gastanaga is arguing happens instead is that the collapse not only halts short of completely crushing the matter, but reverses course, a bounce, moving outward in his terminology. What emerges on the other side of the bounce is a universe remarkably like our own, Gastanaga explains. Even more surprisingly, the rebound naturally produces the two separate phases of accelerated expansion, inflation and dark energy, driven not by hypothetical fields, but by the physics of the bounce itself. It's a fascinating explanation, but there's a lot that remains to be proved. It relies on discounting some very well-established physics behind singularities. The standard model may not be perfect, but it's the standard for a reason. It'll take a lot more to dethrone it, and Gastanaga is optimistic that future missions like the European Space Agency's Arrakis, Arrakihs, which will study invisible structures of dark matter to test the model, could reveal the answers we're looking for. So, I mean, I don't really like the theory that our universe is currently existing in a black hole. That doesn't really seem to make a whole lot of sense to me because, when matter falls into a black hole, it's getting crushed into that singularity, and what happens to it from there, we don't know. I mean, it infinitely dense. I mean, if it's infinite, I guess it would just technically keep falling into the center forever and ever, which is kind of mind-boggling to try to imagine that because, I mean, even those stellar mass black holes, are, like I said, they're like 10, 15 miles across. So how can it forever fall inside a space that's only 10 miles in diameter? And that's not the black hole's overall size. That's just the event horizon. That's just at the point where light cannot escape the gravitational pull of that black hole. So I don't know. I kind of prefer, I mean, not prefer specifically, but I kind of like my theory a little better because, it doesn't explain what happens in the black hole as it exists, but what the future of the black hole will be. And it also explains how our universe got started, which would have been from a black hole being pushed out, squeezed out of another parent universe until it's no longer trapped by the physics, the gravity, all the laws that are tied to that universe. And once it's been pushed out of that fabric from that parent universe, boom, explodes into a big bang, and here we are. And it has very similar, if not the same laws of physics, perhaps, which allows for black holes to exist in our universe, just like any other universe that might be out there too. So, yeah, I don't know. It's thought-provoking. I like this article. It was interesting to go through, so hope you enjoyed. Thanks for watching, and see you later.